Example 6. Let's find some intervals of data. It says weightlifting. Maximum bench press weights in pounds in a local gym are normally distributed with a mean or an average lifting weight of 265 and a standard deviation of 45 pounds. If a weightlifter wants to be in the top third, what must he press? So we're looking for how much would he have to lift to actually be in this value here. So let's go and plug in our numbers. We know that the mean in this situation is 265 and the standard deviation is 45 pounds. I'm going to zoom fit our data. And so I want just this top third. Notice this is one tail. That's one tail. And the A value is 1/3. I'm going to do it like that so it's exact. So I'm going to come to my calculator and say it's A is 1/3 with one tail. So here are the z-score values, and I'm going to put this as an x, so it gives me my graph again, and I need to actually adjust this so I can see as high as 1, because cumulative function only goes up to 1. So you can see this would be the value right there. That's the value indicating the weight at which we would be is 284 pounds. So he must be able to press at least, and since there's decimal, I would say needs to be able to press, he needs to be able to press, I'm going to go ahead and raise up a pound, press at least 285 pounds. Now you might be thinking, how did I just get that? I went one tail at 1/3 and it produced this value, which was shown right here on this picture. Now, if you did not want to use that picture, could you have used something else? Yes, using this z-score. So that z-score is going to be finding out what the value, the percentage is right there. And you would have to work backwards trying to multiply it out times this weight and the standard deviation. So let me actually try this. Before I speak, let me make sure this is accurate here. 4.307. I'm just going to stop there. That's the z-score. So if you were looking at it this being 0 and 1, this would be 0.43 of that one standard deviation length. Well, this standard deviation is actually 45 pounds. So I'm getting 19.38. That would be the standard deviation to get you to that point right there. I took that 0.43, times it by this standard deviation of 45, kind of scaled it out, and then you would add that to that mean. So the mean plus that 19.3815 gives us 284.382. Look how close we are there. You can see that's another way of getting the same value. All right, let's try part B here. Part B. Maximum bench press weights in pounds in a local gym. Okay, same information. It says, what range of lifts will put the lifter in the middle 80% of the distribution? So looking at this graph, there are two tails. It doesn't matter if they're included or if they're the part that's not included. It doesn't matter. But we say there's two tails. Two tails. Okay, and so the A value is the area on the outside, which would be 20% or 0.2. So what I'm going to come over here and do, now let me delete this, is we're saying A is 0.2, but there are two tails. And I want to know, same situation, I want to know this middle 80%. And so this time it's giving me these z-score values, but if I look, if I can lift anywhere between these two weights, I should be in the inner 80%. So if this is 10%, this is 10%, by the way, just to make sure we're clear on how we get to 100. This is 10% here in the data, 10%, and this is another 10%. 40 and 40, all that adds up to 80. 80 plus 20 is 100. Okay, so how much weight would this person need to lift? Anywhere in between 207 and let's say 322 pounds. You might say, why did you not round up? I could have, but I'm really wanting in between, and since I'm treating it as a whole number, we'll put the lifter in the middle 80%. Okay, so how else could I have done this? Well, we typed in our values, and I see the z-score come up. So that means I need to take this, and that is it. The z value you use if your standard deviation is 1. It's not right now, it's 45. So I would need to actually scale this z-score value out. So 1.28 times my standard deviation of 45. That's what I would need to add and subtract to 265. By the way, the negative will give me the same value, just a negative. So I would take my median, or my mean and median are the same thing on a normal, and I add that 57.6, and see we get 322.6, and then I would do the same thing, but 265 minus 57.6, 207.4, 207.3. You can see how similar they are. Anywhere between 207 and 322 pounds will put us in the lifter in the middle. So you could also use, you see how they use these symbols? I could just say x 207 needs to be less than x, which is less than, I'm going to say now 323 because I'm using the less than symbol. It's not equal to. So to be within here, I would need to be greater than 207, but less than 322.67. So less than 323, counting in whole numbers, would work right there. And I'm going to go ahead and just put 323 just to be consistent. And on the previous problem, you would say x needs to be greater than or equal to 285 pounds. That would be the answer this time. Okay, now you can try this problem here.